Okay, section 7, quadratic functions and their graphs. So a reminder of standard form of a quadratic. So ax squared plus bx plus c. So please remind yourselves, read through this, of what the value of a does to the graph of the function. Okay, complete these 3 problems for homework. All right, looking at the graph, intercepts, y-intercept, the one point where the graph will cross the y-axis. The x-intercepts, the 1, 2, or possibly no intercept. Recall that the discriminant tells us the number of real roots of a quadratic. So we can have 0, we can have 1, or we can have 2 real roots. And then lastly, every quadratic has an axis of symmetry. So imagine folding the graph on this vertical line, then whatever's on the left-hand side will match up perfectly with what's on the right-hand side of the graph. The vertex of a quadratic, the vertex can be the maximum or the minimum point, depending on if the parabola opens up or down. Okay, so find the intercepts, the vertex, the line of symmetry, and a quick, simple sketch. Okay, so our y-intercepts occur when x is equal to 0. So if we set x equal to 0, we would get y is equal, and I wouldn't expect you to have to write that every time, but our y-intercept would be the point 0, 5. Our x-intercepts, they occur when y is equal to 0. So now this is what your quiz was just on. Okay, all the different ways that you can solve a quadratic equation. I am going to complete the square. Bring the 5 over. I have to factor the 2 out to make that lead coefficient, that value of a, positive 1. Okay, when I complete the square, half of negative 4 is 2. 2 squared is 4. But please remember, when you add to the left-hand side, you're actually adding 8 on there. 2 times 4, I added 8. So now 3 equals 2. I'm going to complete the square here. All right, I divide by 2. All right, now I'm going to take the square root of both sides. I know that gives me my plus or minus. And so I have plus or minus square root of 3 all over square root of 2 equals x minus 2. And then when I add 2 to both sides, so this mathematically is correct for my intercepts, but think about what that graph would look like. Okay, we're not going to be able to graph that number, so we'll just have to approximate it anyway. All right, vertex. Our x-coordinate is negative b over 2a. So a, b, and c. Opposite of negative 8 is positive 8. All over 2 times 2 is 4. So I have an x-coordinate of 2. My y-coordinate, I get that by plugging 2 back in. So 8 minus 16 would give me negative 8. Plus 5 would give me a y value of 3. Okay, so my vertex is a point. Negative 8 plus 5 would give me negative 3. My axis of symmetry, it's just the vertical line. It's just the vertical line through the vertex. Okay, so it's always going to be x equals whatever the x-coordinate of the vertex is. Okay, so my graph, y-intercept at 0, 5. My vertex at 2, negative 3. Okay, now we can't plot the x-intercepts properly, but what I can do, I can use my axis of symmetry here, and I know 2 units to the right of the vertex, I have to be up at 5 again. Okay, that's the benefit of having that axis of symmetry. So when I sketch this in, make sure it extends on both sides, and I mean, for our purposes, that sketch is fine. Okay, complete number 2 for homework. And number 3 as well. Okay, vertex form of a quadratic. So, we saw standard form, vertex form. As the name suggests, you need to be able to determine the vertex of the quadratic. It's a point h comma k, and notice it's the opposite of h. K stays the same. Okay, so that's important. So, oops. Opposite of what you see in the equation, same as what you see in the equation. All right, same directions. Intercepts, vertex, equation of the line of symmetry, and a sketch. All right, so y-intercept occurs when x is equal to 0. 0 minus 5 squared plus 4. So that gives me 25 plus 4 gives me a y-intercept of 0, 29. My x-intercept, now I set y equal to 0. Subtract 4 from both sides because it's already in a form that's easy to be solved. Now when I take the square root of both sides, notice that my discriminant, my root there, is imaginary. Okay, adding 5. So what does this tell me? I have no x-intercepts. Okay, and that'll make sense when we get to the sketch. Vertex. So the vertex, I'm sorry that it keeps moving. The vertex comes directly from the equation. Okay, it's a minus sign, so the opposite of -5, that would give me +5 as my x-coordinate. K stays the same, so +4 as my y-coordinate. My axis of symmetry is the vertical line through the vertex, so x equals 5. Okay, so I'm going to go by 5s here because I have to get all the way up to 25. 5, 10, 15, 20, 25, 30. So my y-intercept is about here. My vertex, 1, 2, 3, 4, 5, 4 is going to be there. Okay, this is also my line of symmetry. A little bit off here. So I'll put this about up here. Whoop. And now notice my vertex is above the x-axis, and because A is positive, my graph opens up, verifying that there's no x-intercepts on the graph of the quadratic. Okay, so that's, if you use the quadratic formula, your discriminant would have been a negative number. All right, so you can complete this one, as well as this one for homework. Be careful of your negative sign here. Converting from standard to vertex, we're going to do this together in class, so don't worry about that. And now let's just talk about our third form. So the third form is the factored form. Okay, and as it suggests, notice, x, it's already in our factored form. So standard form is expanded form, vertex form, and now our factored form. So if I already have a quadratic that's factored, think about what these values give me. This value of m and this value of n, they're my x-intercepts of the function. Okay, exact same directions, intercepts, vertex, equation, sketch. All right, my y-intercept occurs when x is equal to 0. So I get -2 times +2. So I have the point 0, -4 as my y-intercept. My x-intercepts it's in factored form, so I automatically can just set my two factors equal to 0. So I get positive 2 and negative 2 as my x-intercepts. Okay, and if I were to write those as ordered pairs, my vertex, so in order to get my vertex, I'm going to multiply this out. So I get x squared plus 2x minus 2x minus 4. So I get x squared minus 4. That's now my expanded form. So my vertex, negative b over 2a, there's no x term. So x is 0, plugging that back in, and y is negative 4. And yes, it's the exact same as my y-intercept. My axis of symmetry is x is equal to 0, so that's just going to be the y-axis. 1, 2, 3. So y-intercept and vertex, x-intercept at 2, x-intercept at negative 2. My parabola opens up. So there's my sketch. Okay, complete this and disregard this for now. So you have quite a few problems to do on your own.